Okay, we are doing 2.7, which is implicit differentiation. You don't have to write this all down. In fact, I don't think you need to. I just wanted to explain to you what these are. So to start off with, what you're used to seeing, so this stuff over here, those are explicit equations where one variable is usually isolated. That's what we're normally used to seeing, and that's what we've been taking the derivative of. Over here are implicit equations where the variables are all tangled up together on one side of the equal sign. So if we were to take this initial equation, x squared plus y squared equals 25, and if we wanted to make it explicit, if we wanted to isolate for the y, do you see that this form or this form is what we would end up getting when we isolated for just the one variable? Good? So far, all of the derivatives, everything we've been working with has looked more like this form where one of the y was always isolated. And today we're going to take the derivative of these implicit equations, so hence the title, Implicit Differentiation. And as promised, I'm basically just cutting right to the stuff that we need to get out of this. So I've, in green, written basically what you need for today. If we take the derivative of y, because so far we've only been taking the derivative of x, we put a dy dx or a y prime at the end. I'm going to show you exactly what I'm talking about with an example, but for you to have that in your notes or to keep that in mind is going to allow us to simplify things, to make this a bit more quick and easy to work our way through. So I'm trying to scramble up the different notations so that you're familiar with each of them. We've been mainly working with y prime or f prime of x. Now notice here I said if we have this equation x squared plus y squared equals 25 and we want to find dy dx, for starters, do we all get that that's the same thing as y prime or it's the same thing as f prime of x in terms of what we have been working with? Okay, so I just want to make sure everyone's good with that. And then to show you what I mean with this, let's work our way through finding the derivative of something like this. So I could say, instead of dy dx, I can rewrite this to say d dx of this entire thing. So I'm going to say, I've made that way too long, of x squared plus y squared. So I'm taking the derivative of everything on that side, equals, I need to also take the derivative of this side. So d dx, so the derivative with respect to x, of 25. Actually, I want to leave that there so we can refer to it. Okay, so then what we have learned is, or maybe we haven't learned this yet, we can take the derivative of these separately. We kind of have done that when we were just dealing with a bunch of different terms, all involving x. It's the same rule or same idea now that we have a y in there. So I can say d dx of x squared plus d dx of y squared equals d dx of 25. Allow me to make this clear. I'm writing out every single little step. I don't need or want you to do that. I want to make sure you get what's happening in your notes. So, now that we're going through and taking the derivative, do you see that for this part here, the derivative is simply going to be 2x. I took the derivative of it, so I don't need to worry about this d dx business. We already did it. It's done. That's how I write it. When I get to this d dx of y squared, it's going to be plus 2y. So we take the derivative the same way we would with the x, except I need to write dy dx with this. And that's the part up here in green that I was talking about. So this portion here. So when I did this and I took the derivative of the x portion, I didn't need to write anything. I was done with it. I got the 2x and I'm good. With the y, I need to make sure that I'm writing the rest of this. And then over here, the derivative of 25, well, what's the derivative of a constant? Is just equal to 0. So I can simply write that this all just gives me a 0. Okay, so I want to carry on up here because I'm running out of room. It actually asked me in the question to find dy dx. So to show you or remind you, that's the pink part that we're talking about. So I just need to use my algebra skills to rearrange things to isolate this. So up here, do you see that I would have 2y dy dx equals, I want to take that 2x and slide it to the right side of the equation, so I'd get minus 2x. The reason is in the question I'm looking for dy dx. I want that pink part by itself. So we know using our algebra skills to get rid of this 2y, I can divide both sides by 2y, and that would be gone. So far, so good? What I was looking for, if I go back to my question, dy dx, I found it. I just need to isolate it a little bit more here. So my dy dx, or my derivative of y, with respect to x, is just equal to, well, I can cancel those out. So I just end up getting negative x over y, and that's my answer. That is implicit differentiation. If we view it that way and take out all the other unnecessary stuff, I think you'll find it's not too bad, but this does have a kind of bad reputation because you can probably see that there's some potential there to get mixed up with things. If you take this approach and know what it is you're looking for, I think you're going to find it's not too bad. Are there questions before we move on to part B and see what we get to do with this? Good? Part B says find the equation of the tangent line to the circle, blah, 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 at negative 4, 3. Okay, so I'll rewrite it. So we just found that dy dx is equal to negative x over y. So I'm just looking at making use of what we just found. Right? Well, if we know that dy dx is negative x over y, we have everything we need right here. So I can just simply take it and plug it in. I know that my x value is negative 4. Again, there's no way I actually need you to write all this in, but if it's negative x, then it's technically negative 4 that we're working with. And our y value is 3. So do you see that after doing this, I just get 4 over 3? So that's the slope of the tangent at this point, negative 4, 3. It asked me to find the equation of the tangent line. So yeah, I found the slope, but now I need to take it and put it into an equation. And have you noticed yet, the back of the book often, they put the, like we could write it as y equals mx plus b. We could write it as point slope form. We could put it in general form. Usually for whatever reason, they put it in general form. Let's take the easy route. Does that sound good? If we know a point slope form, like we just found the slope, is probably going to be the easiest for us to work with. But maybe you don't quite remember it, so I'll build in some review. So therefore, our equation, there's my abbreviation for equation, is, well, in point slope form, it'd be y minus whatever I have there, so 3, equals the slope, which is 4 over 3, times x minus whatever we have there. So do you see minus 4 would give me plus 4? So after all this work, our actual equation, because that's what we were looking for, would be this. See what I mean by it's a whole bunch of review, same old things that keep coming up, but we do add on something a little bit new each time. But if you look for the similarities, it doesn't feel difficult, hopefully. Questions? So far, so good? Okay. Let's do one more. One more that has a lot going on. So, same thing, we're looking for dy dx, but we have way more stuff happening. Don't let that throw you off. We're still going to take the same approach. And so, maybe to make it easier, I'm going to split it up, and I don't know, I'm going to call that term 1. I'll color code it so we can see exactly what is happening. We do the same thing that we usually do. Taking the derivative of that, by now we see and recognize that's the power rule, and we'd have 10x to the 4. So that's good, allows us to take care of that part. Here's where things get a little more complicated. Let's do the same type of thing with our second term here, but there's more stuff happening with the second term. Do you see in the second term that we're taking the derivative of two things that are being multiplied together? What do we normally do when we're taking the derivative of something that's multiplied together? What's it called? The product rule, right? So that's what we need to think of, or we need to consider as we work our way through this. So we would have, if we want the derivative of the whole thing, I'm going to write this whole thing out because I think that this is the part that's going to maybe cause you some confusion, but hopefully not if we set it up this way. So we're taking the derivative of that whole term, and when we take the derivative of that whole term, we would have x to the 4 times d dx of y plus y times d dx of x to the 4. Again, I am just writing this all out so that it's super clear to you. Do you see that that is just us writing out the product rule to make it super clear? So then when we work our way through this, do you see that we would get x to the 4 dy dx plus 4x cubed, when I take the derivative of this part, I'm going to shrink that down so we can fit it all in, times y. I feel like it's not super clear. So, how do I use the colors to... This part, do you see that we would simply get this part? Because when I take the derivative of the x4, I can drop this d dx notation that I have written, right? But when I did that for this part, oh, that didn't work, that color. Let me do this. If I did it, when I did it for this part, I needed the dy dx when I took the derivative of my y there. Does that make sense? And the derivative of this y was just the number 1. Are we all good and okay with how we came up with that? Okay, so then we still need to do this third one that in all of this, it's easy to get lost or to miss out on some of these. When we take the derivative of our last one, do you see that we would just get the derivative of this? There's just the one thing going on there, so it's just going to be 5y to the 4. But if I'm taking the derivative of y, we always put this dy dx after it. That's why I wrote that stuff at the start with the big star and green writing. Okay, so I have dealt with them all separately, and now we're going to put it all together. Good? So we need to differentiate the whole thing, both sides of the equation like we did in the last example. I just chose to split it up because there was so much stuff happening. And maybe to make this crystal clear, I'll circle because there's a lot happening in term number 2. So we have 10x to the 4, which allows us to take care of that part, plus we take all of this part. So x to the 4, can I move it up here? X to the 4 dy dx plus 4x cubed y plus this one here, plus 5y to the 4 dy dx. And then the whole thing is equal to the derivative of our 36 here. So do you see I can set it all equal to 0? Are we all okay with that so far? Okay, I'm going to take this all and move it up here. And actually, before doing that, maybe I'll just show you what we're going to do. We are looking for dy dx. It's right there. And it's right there. The rest of this is us applying our algebra skills to get dy dx by itself. So, do you see that I can take this, wrong color. I can take this 10x to the 4 out of there, and I can take this out of there and just leave the stuff that has the dy dx there. So on the other side, and I hope that you're going to be okay with me writing it this way, I would have, can I pull this off to fit it all in one line? I think I can. I would have negative 10x to the 4, and then I would have minus this 4x cubed y. Everybody good with what I've done? I just moved it to the other side, and by doing that, this became negative, this became negative, but they're out of the way. Okay, so that leaves me with this and this. Do you see that I can factor out dy dx out of those? Everybody see what I'm doing there? So dy dx, which also happens to be the thing that I'm looking for, I can factor that out of this, and I can factor dy dx out of this. What's it going to leave me with? It's going to leave me with this x to the 4 plus 5y to the 4. Does everybody get that? So do you see that I can divide that out on this side? X to the 4 plus 5y to the 4. I would have factored out the dy dx. That's the portion that would have been left, and I just divided it on both sides to get rid of it. So after all of that, here's my answer for what my dy dx would be equal to. Good? Do you see the importance of organization? Because this wasn't super difficult, but it looks like a nightmare. And that's because we have a lot of things to keep track of. But if we take this step-by-step organizational approach, I think you'll find it's not too bad, hopefully. Are there any questions with that part? Because we're not quite done. Okay, I lied. We didn't do it in 10 minutes, but whatever. It's still good. Is it good? For the last part, if we want the slope of the tangent at this point 1, 2, do you see the pattern of the same old thing we do over and over again? What do I do with that 1, 2? I plug it into there, right? So, I hope this is okay, I'm going to move it out of the way so that I'll rewrite it for you. But we want to take this and plug it into what we just found. So in our dy dx that we just found, we can say negative 10, and I'm going to plug in 1 for my x value. So instead of x to the 4, I'm going to get 1 to the 4 minus 4 times 1 cubed, times 2 from my y value there, all over 1 to the 4 plus 5 times 2 to the 4. And yes, I am sort of just like plugging that all in, but you see that that's what we just got over here. I simply plugged it into there, and I'm also going to assume you're all okay with crunching the numbers, plugging this in, spitting out an answer, and we would get negative 2 over 9 when you do all of that. And there is your work for today. I am going to say this. Well, I already did sort of split them up. I said odd letters, but remember what I said last day, where you decide if you are doing the first. I would say don't do the first ones. If you're doing the last ones and you're getting it, you don't need to do all of them. You decide.